Hey guys, we're going to be talking about today how to solve for a missing angle in a right triangle using trig ratios. Alright, and kind of a good question for you to take away from this video is how do I undo a trig ratio? Alright, so first let's just jump into a problem. So here we have this triangle, okay, and I'm sorry my drawing is really bad, but it's triangle ABC, alright, and we have this theta right here, and we know that this is length 4 and this is length 13, and we do not know this length. Alright, so the instructions are solve for the missing angle, or maybe solve for theta, okay? Either one of those instructions would be good. Solve for the missing angle or solve for theta, okay? So, what we need to do first is recognize this is a right triangle. In right triangles, so far we've learned stuff about Pythagorean theorem, and we learned stuff about trig ratios. Pythagorean theorem only helps us solve for missing sides, which is not the instructions for this problem. We want to solve for a missing angle, alright? So here's my angle, alright? So I want to solve for this, so I need to use trig ratios because all three trig ratios, sine, cosine, and tangent, all deal with angles, okay? Because they're all sine of some angle theta, cosine of some angle theta, and tangent of some angle theta. Alright? So all three of these deal with angles, okay? So we can use that to solve for this missing angle. Alright, so first let's label the sides of our triangle in reference to theta. So first off, the one across from the 90 degrees, so across from the right angle is always the hypotenuse. So this is our hypotenuse. The one across from theta is always our opposite. So this is our opposite, OPP. And then this one right here is our adjacent. Now, we want to solve for theta. So we need to ask ourselves, okay, in reference to theta, we know the opposite and we know the adjacent. So which trig ratio deals with opposite and adjacent? That's right, tangent. So I can say tangent of theta is equal to opposite over adjacent, so 4 over 13. Now the real question comes in, okay, so how does this help me solve for theta? Well, we have tangent of theta. So if there was a way that we could remove tan, we could then solve for just theta. Well, how do I get rid of tan? Well, how do you get rid of any trig ratio? You do the inverse of that trig ratio. So the way you get rid of tan and all the other trig ratios is you take the inverse of that. So for tangent, it would be tangent raised to the -1 of tangent of theta, which is then equal to 4 over 13. Oh, I'm sorry. What you do one side, you must do to the other. So I need to be taking tan inverse of this side as well. So tan inverse of 4 over 13. Okay. So tan inverse and tan cancel each other out. They remove each other. So now I have theta is approximately equal to, and we will use our calculator to tell us the rest of this. If I can get my calculator turned on. This is like a daily thing. Okay. So we're going to say second tan of 4 divided by 13. Press enter, and bam, 17.1 degrees. So theta is equal to 17.1 degrees. Okay, how about we try another problem? Okay, so here's our next problem. We have some triangle ABC. It's a right triangle, alright, and here's our theta, and I want to solve for theta again. Alright, so the first good step is to label your triangle. So across from the right angle is always your hypotenuse, so this is your hypotenuse. Across from theta is always your opposite, so this is your opposite. And then next to theta, that's not the hypotenuse, is your adjacent. Okay? So now I can think, okay, I want to solve for theta. This is a right triangle, so I want to use trig ratios. Alright? So I know the adjacent and I know the hypotenuse. Which trig ratio deals with adjacent and hypotenuse? That's right, cosine. So I can say cosine of theta is equal to the adjacent, which is 6, over the hypotenuse, which is 9. So now I need to solve for theta. So how do I get rid of this trig ratio? I undo it by doing the inverse of it. So I say cosine of -1 of cosine of theta, okay, is equal to cosine of -1 of 6 over 9. Alright, so on this side, the cosine -1 and the cosine cancel each other out. So now you get theta is approximately equal to, and we'll use our handy dandy calculator. So we'll say second cosine of 6 divided by 9. Oh, I didn't get second cosine, did I? I just got cosine. Second cosine. 6 divided by 9. Press enter, and I'll get 48.2. So the measurement of the angle is 48.2 degrees. All right, guys. I'm just going to give you those two examples because I think you guys understand this topic pretty well. Be aware that instead, if this, for some reason, let's just pretend that we needed to have a sine theta, the way you get rid of sine theta, the way you get rid of sine is to undo it by doing sine inverse. All right, it's just like the other two trig ratios. Okay. All right. Please let me know if that does not explain everything. Please let me know if you have more questions. All right. Thank you for everything. Have a great day.